Hey everybody, welcome in. Today we're going to be learning about forces and friction. Thanks for being here. And this is an exciting subject to learn about because there are pushes and pulls everywhere. There are forces everywhere. And once you understand what to look for, you will see these forces and friction all over the place. So let's get into this. So a force is defined simply as a push or a pull. It can get a lot more advanced than that. We're going to stick with that definition for now. And it's measured in a unit called newtons. And that's abbreviated with an N, and 1 Newton is 1 kilogram times 1 meter per second squared. Now in lab, we'll measure force using a spring scale, often or not. But we will also use things like force meters, force plates, and there's all kinds of other instruments that can help us measure force. Now, force is a vector. It has a directional component. We have to know where that force is pushing, what direction it's going, and we use arrows to represent that direction. So whenever we look at models and diagrams using forces, we have an arrow that will show us what it is, what direction that is going. So let's take a look at what I mean here. So here is a ball here. Now, if I push it to the right, if I apply a force, right, a push, there you go, it moves to the right. Simple, right? It seems like common sense, but it is not just common sense, it is science. Right, and then we go on this side. We'll now push it to the left. All right, there you go. All right, the ball is now moving to the left. I applied a force to it. I push it forward. Oh, look at that. There's a force that way. It goes that way. So it goes the direction where you apply that force. Now, what you need to do is, what would it look like if you were to model this and you were to draw an arrow, right, making this go to the right? What would it look like if you drew a model and you had it going to the left? Where would you put that arrow in a model pushing this ball? Now, balance forces are forces that are the same magnitude, right, the same strength, but they are in opposite directions. I am pushing this ball into the wall. It's not going anywhere. You know why? Because there is an equal force pushing back. All right, so the makers of this game in their physics engine, they made it so it goes in that opposite direction. So I push the ball, all right, and this wall is pushing the ball. There's no change in its motion. A little shift here and there, but there's no change in its motion. You know, I'm pushing into it because the forces are balanced. They're the same. So if you add up all the forces acting on an object, you end up with a balanced force, and there's no change in its motion. That is called the net force when you add up all those forces. Now, if we look over here, we have some ice. Let's talk about friction. Friction is a force that opposes motion. So if you're going in one direction, you're pushing one direction, friction pushes in the opposite direction. Now this surface obviously has a different friction than the other surface. If something has less friction, generally it's smoother. Now this is sliding friction. When it's just two objects sliding past each other, even me just rubbing my hands together, sliding friction. One object goes one direction, friction goes in the opposite direction. Let's take a look at some other examples of types of friction. So let's think about this. All right, now I have all the kinds of friction written out here. Let's first think about static friction. Static friction must be overcome to get an object going. You ever notice how sometimes it's harder to get something moving when you first start pushing it? Well, that's the static friction. Sliding friction is dragging or pushing something, applying a force to it across the surface, right? Without anything else. You're just kind of pushing it along. Rolling friction is less than sliding friction, right? Requires less force generally because you have wheels, and those wheels have rolling friction. And another kind of friction is fluid friction. And this is when something is moving through a fluid. Air and water are the most common kinds of fluid. And engineers design things to be aerodynamic to reduce that fluid friction. So they have to overcome less force. Now here is some more sliding friction. Just some fun riding around on this. Not a lot of friction on this because it's not even touching the ground. If it actually touched the ground, there might be a lot more friction. But there's not. Okay. Now I have over here a shopping cart. Guess what kind of friction the shopping cart has? Well, that's rolling friction. Check out those wheels, right? Those wheels, rolling friction. Fabulous. If it's got wheels, it's got rolling friction. And for our fluid friction, of course, there's swimming. You're in the water. There's fluid friction. But there's also fluid friction if I'm in the boat. All right, the bottom side of this boat, the water, and the air above even. Fluid friction. It's there. Nice aerodynamically shaped boat here. So thanks for joining me on this journey through forces. We learned a lot. We learned about a force, a push or a pull. We learned about the different kinds of friction and how to model friction. See you next time.